Hey there, this is a background video on probability, and this is the basic stuff that tracks through your chapter 6 of your textbook, just the beginning of it. So first of all, the real basics. You have this section here explaining some basic concepts. So the ones that you need to be aware of, and you can write this down in your notebook, is an outcome, is like a result in probability, okay? The sample space is a list of all the possible outcomes. Okay, and an event is something that happens, or it could be just one of the outcomes, so it's a member of the sample space. Something that happens. And the probability is a calculation. So probability, as is described down here in the box, is usually listed as a decimal between 0 and 1. If you do a calculation one day and it's 1.32, you have done something really not cool, all right? So something's gone wrong. So it needs to be under 0.99 something, and well, 0 is okay. 0 is legit. So looking at the spinner here now, let's do some examples for each of these things. One of the outcomes in the spinner example is that the probability of getting a blue square or a blue outcome. Now I'm going to calculate it as well. So I can see there's 2 out of 8. Okay. So we calculate probability as probability of an event, and that's made up of the number of times the event happens, number of occurrences of event itself, out of the total possible occurrence number, total possible number of occurrences. So 2 out of 8 is blue, and because fractions are okay with probability, decimals are better, so we're going to divide that out 0.25. All right, sample space for this guy here as the example is maybe blue 7, blue 4. We've got green 1 and green 5. And we have light pink 6 and 2. Now I think they've coloured it so that we can just see the difference of all those wedges. It's quite likely that the sample space, if you're just doing numbers, is 1, 2, 3, 4, 5, 6, 7, 8. And those numbers are like not so much counts, they're just kind of like a list of outcomes. And I think we've covered all those definitions there in regards to those things there. Okay, so for the worked example, they have a deck of cards, and it's something you do need to be familiar with. They're asking you in this sample here is chance of selecting a picture card, a diamond, an ace, and a black card. Now, you need to know that the picture cards are the Jack, Queen, King, and we'll include the aces as well. You need to know that you have suites, and there's 4 of them. These guys here, so hearts, clubs, spades, and diamonds. And you need to know that the number in each is like 1 to 13. So 1 is your ace, so ace, 2, 3, 4, 5, 6, 7, 8, 9. Now we have a 10. Now your Jack is your 11 if you play cards, and if you don't, this is just so you know, Jack, Queen, King. Okay, but there's 13 of them, but the sample space is this for the diamonds. 13 times 4 suites is 52 cards total. So that's your total number of outcomes, and we're going to look here at the question. So the chance of selecting a picture card is probability of selecting a picture card. That's the event, and we're going to calculate that event. 4 lots of 4 out of 52, so that's 8 out of 52. On on getting my trusty calculator to work that out as a decimal is 0.1538. Second one we're going to do, let's do ace, probability of selecting an ace card randomly from a one pack of cards. There's 4 aces out of 52, so we're just going to divide 4 divided by 52 equals 0.0769. The next one is a diamond. Now, a quarter of the stack is diamonds, or 13 out of 52, 0.25. And the final event that they want us to compare is probability black. Half of them are black, okay? Half of the cards, or 26 out of 52, which is 0.5 as well. Now they're getting you to think, and they have done this all out of 52. We've gone a little step further here because we have calculated the actual probabilities themselves, all right? So that guy, that guy, that guy, that guy. And what do they want us to do? In order from least likely to most likely. So they have said ascending, so the least likely is an ace, and I think we probably concur with that. So that's the smallest, and then they said a picture card, and our picture card was 0.15, so that's our second highest. And they've got diamonds, which is 0.25, which is the next highest, and 0.5 is the most likely. So you're most likely to select a black card. So just by doing this activity here, I wanted to show you how to calculate probabilities, okay, from cards. You need to also be good with dice, coins, and repeated tossing of coins and dice as well for your basics. Now this little piece here I've chopped from your textbook. It's the next little section in 6.2, chapter 6.2. And what it's basically telling you is if you can guess or do the calculation like we did on the previous slide, then that type of probability, so there's 2 types of probability. Please write this down. The first one is called equally likely. I think they use equal probability or something. So equally likely means that you have a set of cards and you know the distribution of them, so you know the reds and so on. You have a spinner that you can see. They're not exactly equally likely, but it's kind of predictable. Coins, spinners, coins, cards, and so on. Now this other one here talks about somebody writes some letters in a book, and what's the chance that they write particular letters more often than another. So it says that using your knowledge of the world is the way that they calculate that. In probability language, it's more correct for us to say that the other type of event is what we call experimental. So we look back in time and see, or we go and count how many letters are in that person's book, and we don't really know if the probability of getting a letter E is 0.01 or 0. Something else. So what we actually do there is we go and count. Now, so weather forecasts do that. And so we might know the probability of rain in April on any particular month. In the April month is 0.21, 21%. Now we figure that out by going back over old records where someone's recorded all the days and whether it rained or not. So a lot of weather events are done using experimental probability. All right, so one of them is predictable and the other one you have to investigate to check out experimental. And for these ones here, you guys will be looking at both. They will normally give you data in tables or something, okay? Given the data in tables or in the text. And they're not predictable numbers. It's not 50-50 rain. It's not how the world works. So someone's actually recording those values from experiments, so scientists usually. Okay, here's an example here of weather. It shows that it has rained on Christmas Day 12 times out of 80 of the past years. Describe the chance of it raining this year. They use unlikely, so 12 out of 80. So probability of rain on Christmas Day, let's go 2020, is 12 divided by 80, and we divide that out as a decimal. It's 0.0125, so that's about 1.25%. Okay. I don't know why they didn't give you that in this example, but what I've done here is I've given you the probability of the event. I've given you the number of times that it occurs, number of occurrences of that event, divided by the total number of total outcomes. So they counted 80 Christmases. So that there is our formula for experimental probability. That's how it works. It's a fraction that you develop from the information you are given. Note that down somewhere, okay? That's going to be handy for you. Make your own notes as you go. Alrighty, let's do this first one together. You can stop this video if you want to have a go by yourself. What I'm going to do is just do this question here, number 1, and then you guys can carry on this background topic. Okay, so they just want you to use these terms here. So they want you to describe the chances of it occurring as either impossible, unlikely, even, probable or certain. So question A is rolling a dice and getting a negative number. I'm going to do, I'm going to calculate it. Negative dice result. We don't have negatives on dice, do we? So it's 0 out of 6 possible outcomes, which is 0. So we can answer that one as impossible. We've answered the question and the evidence is down here. Question B is rolling a dice and getting a positive number. So probability of positive. All the sample space of a dice is 1 to 6. They're all positive, so 6 out of 6, which is 1. Okay, so that one there is certain. C is rolling a dice and getting an even number. So if we look at our dice up here in the sample space that I've listed, 1, 2, 3 even out of 6 results. So probability and even is half of them. 3 out of 6 is 0.5. Now how I'm writing these through here is exactly what you need to be doing when you answer your questions, okay? So none of this straight to the answer business. You just actually need to do all this at your level, eh? Okay, next one is rolling a dice and getting an even. So we've done that. So in this language here, it's 50-50 or even chance. That's exactly 50%, not 49. Okay, D, selecting a card from a standard deck of cards and getting a red. So D is the probability of getting a red card. Half of them are red, okay? So 26 out of 52 of the cards is red. And again, that's even, 50-50. And selecting a card from a standard deck for E and getting a spot or a numbered card. So I didn't know what a spot card was, but I'm glad they told me. 1 to 10 with the ace being the 1. So 2 to 10 is 9 cards. So it's 9 times 4 is 36 out of 52, or 9 out of the 13. That's the same fraction. So if I just divide that out to get the decimal, 9 divided by 13, 0.69. That seems right. More than 2/3 really. 6923. So what are we going to put? We think probable or certain. Well, it's better than 50-50. It's 0.69. So I think we're going to get a probable. It's not certain. It's not 100%. But it's more than halfway. So we'll use that middle term there in our scale that they've asked us to use. Okay, question F. Selecting a card from a standard deck and getting an ace. There's how many aces in a pack? 4 out of 52 or 1 out of 13. Same. You don't have to do that. So 1 divided by 13 in my calculator is 0.0769. What are we going to call that? It's not even chance. It's less than 50%. It's not impossible, but it's not too likely because it's 7%, so it's less than 10%. So I like this one here, unlikely, would probably be our best bet for that one there. I should have put the percentages here, okay, but you'll answer it more comprehensively. I'm just coming back and writing those in there. Or I can put that in there as well, unlikely. Okay, next one, reaching into a money box and selecting a 30-cent piece. I don't think we have 30-cent pieces. So just by virtue of the definition and thinking about it, I think that would be impossible. I don't think there's probably too many currencies that have 30s because a 2010 is more versatile, and so most currencies would work like ours where 30-cent pieces don't exist. And selecting a blue marble from a bag containing 3 red, 3 green and 6 blue. That looks like half, eh? So let's do, let's put G there. Probably 30 cents equals 0. And H, probability of blue. That's our event, and the total number of blue is 6, and the total number of marbles together is 12. So again, that's even chance, 50-50. Okay, probability calculations work, and these ones here tend to be equally likely, or we can use an equally likely scenario like a dice. Those numbers are equally likely, and we can delve in a little deeper to see whether they're even, positive, and just thinking about them and applying that formula. Okay, so the number of occurrences of interest divided by the total number of possible occurrences, the total sample space count, and do the remainder 2 to 6. That's how. Over the page here, here's some questions for you to do. It's that one's similar to what we've done. That one there looks like the weather one. Here we have some data on a production line of burning. Okay, so that's a quality control one of stuff that's made in a manufacturing plant. This one here is of interest too, a practical problem. And here we have another bag one. So they're very similar to the ones that I've done. So if you go ahead and do those, I will drop the results on paper into your resources. Okay, enjoy that. Make sure you do these, and make sure you have a drink and pat yourself on the back afterwards. Not a hard drink. Have a drink of water and pat yourself on the back.